or session. A few housekeeping matters. Well, I guess first, you're here for the Enhanced Pedestrian Crossing, planning to construction. Our speakers today are Jamestaun Kraupp and Nick Gross from Kittleson and Associates. Presentation's not moving. There we go. So on October 13th, we have Lynn Road reconstruction improvements with Robert Miller and Greg Rennies. Hope I'm saying that right. We'll send out the notice for that here soon, but you can also go to the chapter website and sign up for that now if you want. And then as of yesterday, the registration for the fall virtual conference went out. So details are available on the website, or you can email me if you didn't get that, and I will send everything your way. As I mentioned, today's presentation is the life of an enhanced pedestrian crossing, planning to construction. Feel free to put your questions in the Q&A box within Zoom. And there's going to be a little bit of a switch between Nick talking and Jamestaun. So at that switch, we will answer questions for the planning side of things, which is what Nick's focus is. And then at the end, we'll answer questions for construction, which is Jamestaun's focus. So with that, I am going to stop sharing my screen and turn it over to Nick and Jamestaun.
Thanks, Fred. I'll just get a quick check. Fred, can
see
you?
Your screen and hear you.
Great. All right. Well, thanks for the introduction. Yeah, so as Fred mentioned, today's presentation is titled The Life of an Enhanced Pedestrian Crossing, and we are going to be walking you through the life, meaning the planning stage through design and into final construction of what we typically think of as some form of a enhanced pedestrian crossing. Let's see. So this is a outline of today's agenda. I'll be walking through steps 1 and 2. As Fred mentioned, we're kind of framing that as the planning phase of a given project, enhanced crossing project. We'll pause for planning questions, and then I'll pass it off to Jamestaun to cover the design and construction piece of the presentation. So a little bit about ourselves. Again, my name's Nick Gross. I work as a planner here in the Kittleson, Portland office. I have about 7 years experience, and the majority of my work focuses on active transportation planning and concept design. I do a lot of pedestrian crossing assessments and work closely with our design folks on getting those implemented. Jamestaun, do you want to go ahead and introduce yourself?
Yes, hello. My name is Jamestaun Kraupp. I'm a recent engineer with about 6 years of experience. Most of my work is around roadway design and construction with a lot of ADA accessibility, and I've been doing a lot of these enhanced pedestrian crossings over the last couple of years, so fairly knowledgeable in them.
Great. Okay, so moving on. So I thought a good starting point would be to help define at a very high level what we think of as a crossing, and also what is sort of the legal rules and legalities of the national and local practices. So you may have seen a poster floating around at either a conference or at a jurisdiction office or something like that that says all intersections are legal crossings in Oregon. So I thought first it would be important to think about, do crosswalks exist at all intersections? And so there's two perspectives on this. They're essentially the same, but the national practice is that a crosswalk at an intersection is defined as an extension of the sidewalk or the shoulder across the intersection. And that would be regardless if it is marked that way, as in striped with a crosswalk, or not. So again, the national practice at an intersection, all crossings are legal crossings. A mid-block crossing is only a legal crossing if it is striped as a crosswalk. So if there's no crosswalk or striping at a mid-block location, it's not technically a legal crossing. And then the Oregon law is very similar and essentially results in the same conclusion, but is framed a little bit differently. It states a crosswalk means any portion of a roadway at an intersection or elsewhere that is distinctively indicated for pedestrian crossings by lines or other markings. So when do vehicles have the right of way? When should pedestrians yield to vehicles, and vice versa? So the definitions I just talked about on the previous slide should answer this question, and maybe you already have the answer, but so every pedestrian crossing a roadway at any point other than within a marked crosswalk or within an unmarked crosswalk at an intersection shall yield the right of way to vehicles. So a pedestrian commits the failure to yield to a vehicle if the pedestrian fails to yield the right of way to a vehicle at any point other than a marked crosswalk or an unmarked crosswalk at an intersection. So that's kind of the legal background, technical side of things. That is, I thought would just be some useful background information. There's a lot of practice and a lot of, well, I guess not everything kind of follows through to the legal world of crossing. So anyways, let's get into our steps in the life of a enhanced crossing. So the first is really going to be establishing the need and answering the question of why would we want to install a marked crosswalk or some kind of enhanced crosswalk? And we typically, the starting point is Jamestaun or I or someone at our team will get a call and from a local jurisdiction, and they'll have some interest in providing some form of enhanced crosswalk, or at least evaluating what an enhanced crosswalk potential could be. So some of the main reasons why we do that are maybe there is a recent Safe Routes to School plan that's been adopted, and you know, there's a desire for some kind of enhanced crossing that's close to a school. Another popular request is due to some kind of new development that may be increasing activity in a given area. There may be some activity generators on one side of the street and new development on the other. There's also unique circumstances. And this is a photo of a project that I recently worked on. This is the Fano Creek Trail in Tigard, which floods during our rain season here. And this essentially creates an impassable trail and requires trail users to travel up to the existing at-grade roadway to cross. And then the most popular, and I've hinted at this a little bit with the new development, is really just the desire line criteria or interest. So in this sequence of photos, you can see this woman. The photo's taken from a transit stop. There's a Fred Meyer across the street. It's the most direct route. It has, I guess, is perceived to be somewhat safe, since you can see this woman is crossing the street. And so this is another very common reason why, you know, someone may reach out to us to evaluate the potential for an enhanced crosswalk. The last, which I did not include a slide for, and I did that intentionally, is for some kind of crash history. Maybe there's been a fatality, and I didn't include a slide because at that point, it's typically too late for, you know, mitigation or including or proposing some kind of safety countermeasures. Although, of course, if there has been a fatality, we do typically go out and will conduct a road safety audit or some kind of assessment leading to future countermeasures. But I just wanted to kind of emphasize the point that a lot of this can be done and should be done prior to a crash occurring. So step 2, this is going to be really the bulk of our work. So the planning and facility analysis piece of this. And I'm going to walk through one of the recent projects that Jamestaun and I just completed and show some examples of kind of the life of a planning pedestrian crossing assessment. And so again, our starting point, we've kind of defined at least the need on paper. We've spoken with the client or the jurisdiction or whoever it may be to understand kind of their perspective on what the need is. And then our starting point after speaking with them is to really gain a much broader understanding of the surrounding context of the area, that being sort of the active transportation network. And by active transportation, I mean walking, biking, and generally rolling. So the sidewalk inventory, bicycle inventory. Are there schools in the nearby area? New development activity generators? These are the things that I was talking on as kind of the need. And at this study area photo here, you can see that there's new development going in on the east side of the roadway here. I've highlighted our study intersection, but the study area is really that broader aerial photograph. So there's new development on the east, there's a downtown core and other commercial generators on the west. I believe there's a school going in a little bit further off the screen to the east here. So this intersection had a request to kind of just take an initial look at what may be feasible and recommended based on national guidance for enhanced crossing. So as I mentioned, our starting point, we're going to go out in the field. We're going to start collecting a lot of existing condition data. We're going to be reviewing a lot of background material. If it's in a incorporated area or if a city has a TSP, we'll be looking at the transportation system plan. Are there any recommendations at that intersection or mid-block crossing location that have already alluded to some kind of need for an enhanced crossing? Who owns the roadway? Is it an ODOT facility? Is it a county facility? Is it a local city facility? There's different guidance and kind of procedures that would follow for each of those. Functional classification and cross-section. Cross-section, really, the key takeaways on that are going to be crossing distance, and everything that I'm going to talk about sort of here out to the analysis is all going to be data endpoints that inform the analysis. Roadway characteristics, this is what we think of as our traffic data collection. And what we typically end up collecting are traffic volumes. We'll more commonly get 24-hour tube counts to understand the peak vehicular time periods. We'll also with that get speed, which is a critical piece to the analysis in determining not just the posted speed, but what that 85th percentile speed is. Well, then if it's at an intersection or nearby an intersection, we'll get turning movement counts, which would include non-motorized activity, that being pedestrian crossings or bicycle crossings at all legs of the intersection. And we also typically like to get a nearby or adjacent intersection turning movement counts as well, to understand, are there people crossing at the next intersection down the street, because maybe that's perceived to be a bit safer. Maybe they're going out of direction to cross at a perceived safer crossing, but if there was some kind of enhanced crossing at our study intersection, maybe they would be crossing there. So adjacent land uses, I've touched on this a little bit in that study area overview, but what is immediately adjacent to the crossing? Is it part of a trail network? Are there commercial uses on one side of the street and residential on the other? What's going on in the immediate adjacent area, and then what's going on in that kind of next level broader context of the area? topography is really going to end up going into a site distance analysis. What are the vertical and horizontal curves of the roadway? Site distance, I just mentioned that. We'll inventory the curvature, the vertical and horizontal curvatures, and conduct a site distance calculation. We typically do both a stopping site distance and an intersection site distance calculation to determine kind of, it's basically a fatal flaw if the site distance isn't met. And that could be an early deterrent of installing an enhanced crossing. If scope or budget allows for it, we also typically like to conduct a yielding compliance assessment. So what is the percentage of vehicles yielding to pedestrians at the intersection or mid-block crossing today? And how does that compare to the national averages of motorist yielding compliance? The national averages, there's some research on that I've shown here, NCHRP 371. And some other roadway considerations. So traffic control, upstream signals, downstream signals, uncontrolled crossing locations, signage, is the intersection or mid-block crossing well lit? And if it's not, we'll probably end up making a recommendation that it should be, regardless of an enhanced crossing. And then the crash history, of course, I've talked a little bit about that as well. So those are the roadway characteristics as our starting point, and then we'll get into some of the pedestrian characteristics. This is kind of merged with our traffic volume data or traffic data collection, but really we want to understand what's going on out there today in terms of a non-motorized activity. Crossings, the peak hour of pedestrian crossings may differ and probably does differ than the vehicular peak hour. And then again, to emphasize the adjacent intersections, there may be crossings occurring that are people going out of direction to cross at a perceived safer crossing because the study intersection is just not safe to do so. And then lastly, walking speeds. These are two sort of binary metrics we use based on typical crossing speeds and research conducted as part of the NCHRP 562 research report, which I'll get into on the next slide. But really, so 3.5 feet per second is the typical walking speed for a able-bodied human. 3 feet per second is something we don't often do, but would typically be done when you are working adjacent to, say, an elderly care facility or even a elementary school. We'll bump that down, and that is a change of metrics in the analysis spreadsheet. Okay, so now we're going to dive into what the analysis looks like. And these are two documents, analysis procedures, methodologies, guiding documents that we use. The NCHRP report 562, improving pedestrian safety at unsignalized crossings. This one I bet more people are familiar with than the other, which is the FHWA guide for improving pedestrian safety at uncontrolled crossing locations. NCHRP 562, this is typical request on ODOT facilities, and then or really anywhere. The guide, the FHWA guide on the right side of the screen here is, as it says, more of a guide, whereas the NCHRP document is more of a methodology and analysis to determine the minimums of what may be recommended. So I'm going to quickly walk through the pros and cons of maybe each of these and what you should consider as what the approach would be best fit for your jurisdiction or project. So NCHRP 562, all of that background material and data collection that I've talked about is going to feed right into this analysis. So I'm highlighting here the key pieces of that analysis and what we end up plugging into the spreadsheet. And these are the roadway characteristics. So 85th percentile speed, what's the crossing distance? traffic volumes and pedestrian volumes. You know, those differ based on the peak. So we typically run a couple scenarios at, you know, the pedestrian peak hour, the vehicular peak hour, and then the local parameters. Walking speed is pretty standard, but motorist yielding compliance has can vary from low to high, and that's more of a qualitative measure if you aren't able to conduct a yielding compliance study. And you know, it's really just another binary metric of high or low. So kind of what are the outcomes of the potential crossing treatments? Today's presentation is focused on the enhanced or active crossing treatments. I'm also bolding here the red and signal crossing treatments. However, all of these bullets are potential outcomes of the NCHRP 562 report. So if you are not meeting minimum criteria for an enhanced crossing, maybe there are geometric improvements or traffic calming improvements that could be made. Active treatments. These are two that maybe you don't typically think of, or we don't typically think of as active treatments. So the first, in-road warning lights. So these are be kind of flashing yellow, amber lights embedded in the crosswalk. And then pedestrian crossing flags, another kind of not super popular treatment, but sometimes most commonly installed near schools and things like that. So moving up in popularity, we also have for active treatments overhead flashing beacons, as you can see at the top of the screen here. And then maybe our most popular, and what Jamestaun's gonna highlight some more, is the rectangular rapid flashing beacon. These have been a very popular safety countermeasure at enhanced crossings over the years and continue to be so. And then there are red treatments. So a high intensity activated crosswalk or hawk signal. So the difference really between the active or enhanced and then the red treatment is that indication. So a red treatment, as described, would, you know, have some kind of red fully stopped phase as part of the signal, whereas the active or enhanced is going to be flashing yellow. And then lastly, we have some more red treatment. So a pedestrian crosswalk signal. These would typically be located at a mid-block location where there's no side street, maybe a trail crossing, and then a half signal would be similar, but it would be a signal located at an intersection where the side streets are controlled by a stop control. Now I'm gonna quickly walk through sort of two scenarios of what the spreadsheet looks like and kind of answering the question of meeting the minimum to require or recommend a enhanced crossing. So I tried to build these two scenarios as typical sort of roadways you might see. The first would be a roadway with an 85th percentile speed of less than or equal to 35 miles an hour, vehicular peak hour somewhere in the range of 200 to 1,000 vehicles, so a pretty large range. And then the crossing distance I thought would be, you know, 24 to 36 feet, a 2 or 4 lane roadway section. So under this scenario, I think you could think of this as kind of your smaller, maybe neighborhood route or even a minor collector or something like that. 20, less than 20 pedestrians crossing the road in a peak hour is not going to result in an enhanced crossing. At this level, you're going to consider raised medians, curb extensions, traffic calming, things like that. When you bump that up over 20 pedestrians crossing in a given hour, you're going to trigger that active or enhanced threshold. The second scenario is the same inputs, although now we're talking about a little bit bigger of a roadway with a posted speed greater than 35 miles an hour. So under this same scenario with a higher speed, again, maybe this is more of a collector roadway or even a minor collector, posted speed or 85th percentile speed is greater than 35. You're going to need a minimum of 14 pedestrians crossing the roadway in a given peak hour or given hour. So those are two scenarios using the NCHRP methodology on how you might get to an active or enhanced crossing. I'm hoping people have already started thinking about the cons to maybe why this approach isn't always the best. And I'll dive right into that, which would be, this is relying on existing pedestrian crossings occurring out in the world today. And why might those volumes be low? Well, maybe it's not a safe crossing, or at least it's not perceived to be safe. So those crossing volumes are not occurring. And maybe someone's driving their car from their house on one side of the street to the grocery store on the other side of the street because it's just safer to do so. So that's kind of also getting to the point of collecting that traffic data at the adjacent signals or intersections to understand the broader context of what's going on. So the Guide for Improving Pedestrian Safety at Uncontrolled Crossing Locations, the FHWA guide. I like this guide a lot. There's a lot of great information and guidance on all things pedestrian crossing safety considerations. This snippet here is kind of what I think of as the key takeaway of the document. And this is, again, guidance on enhanced crossing treatments or safety countermeasures for road. So it considers roadway configuration, posted speed, and ADT. What it doesn't consider is existing crossing volumes, which is a nice complement to the NCHRP approach, which relies pretty heavily on existing pedestrian crossing volumes. So under this example, you can see this matrix. If you have a 3-laned roadway without a raised median and a 35-mile-an-hour facility, you kind of work your way to that box, and then within that box you'll find a number of countermeasures. The bold countermeasures, or ones bolded in red, black, signify countermeasures that should always be considered, and then the circled ones signify that crosswalk visibility enhancement should always occur in conjunction with the other countermeasures considered. So these are kind of two of the backbone pieces of our analysis that we use on a typical enhanced crossing assessment. And then my work concludes by writing up all of this into a report. We typically make some kind of recommendation based on our findings and what both of these analyses say. I think it's really important to note that, again, if you're really relying on the NCHRP analysis, it's more common than not that you may not be meeting those minimum thresholds for an enhanced crossing. So a lot of the times we build in these scenarios like I was showing earlier and say, well, what if these volumes were to go up slightly, and what if vehicular volumes were to go up slightly, or what if we moved, we know that 10 people are crossing down the street, but we know they're also going out of direction. So a lot of our recommendations ultimately end up being informed by a variety of contexts and are not always directly, if we are recommending an enhanced crossing, it may not meet the minimum thresholds, but we still are recommending it based on the surrounding understanding of the area. So with that, I'm gonna pause before we get into Jamestaun's portion of the presentation, and I guess I'm not sure the best way. I'll maybe defer to Fred on if there are questions in the chat, which I don't have.
We have a few questions, Nick.
Okay. So I think we could probably take maybe one or two, maybe three.
They're pretty short ones, I think.
Okay.
The first one is from Josh Wheeler saying, I've been told that in the state of Oregon, the pedestrian has the right of way, not the vehicle, that vehicles must stop for the pedestrians. Is that your understanding, or is it like other states where the vehicle has the right of way?
So a vehicle should, and the keyword should, so from a legal perspective, should always yield to a pedestrian at an intersection, whether it is striped as a crosswalk or not. At a mid-block crossing location, a vehicle does not need to yield to a pedestrian unless it is striped. And if it is striped, then they shall yield to the pedestrian. Of course, that is not always the case.
And I'd just like to point out, because I saw that question, I just started looking at it to make sure. One, we are not attorneys or lawyers. Let me preface that. So this is just based on research and what we do know about the legality of it. But with a quick Google search and what I find, every intersection is a crosswalk which follows the ORS 801.220, which states that a crosswalk exists in any public road intersection, whether marked or unmarked, and that's where a pedestrian does have the right of way. It's when a pedestrian is outside an intersection, say like in a mid-block crossing where there is no marking and they're choosing to do what it can be considered jaywalking, that's when they do not have the right of way. So a really quick Google, I'll post it in the chat of the links I used if anybody wants to look into it further. Just to be clear of what the ORS is, 801.220.
Thank you, Jameson. And the second questions, there's two of them, but they're short. They're from Emma Newman. Do crossing flags actually work? How often do they wander off and have to be replaced? And then also, is that Excel worksheet available that you use from 562?
Yes. Okay. So the first question, I have never made a recommendation for the crossing flags. I'm not saying they're bad or anything like that. I don't think the context of any of the projects I've worked on would be appropriate for those. I have done a crossing assessment at a school which was currently using crossing flags, similar to the photo I showed. I don't know a whole lot behind the kind of compliance or research behind compliance for the flags. I certainly don't know about them being, if they are at a location of people taking them, but that's a good question. The second question, remind me what that was. Sorry, Fred.
Is the worksheet from NCHRP
Oh, yeah.
562 available?
It is available. It should be pretty easily accessible with a Google search, but again, we can get that either posted in the chat today, or I can work with Fred to figure out the best way to distribute that out. But I believe if you just do a Google search of NCHRP 562, you should be able to find that spreadsheet, and it's pretty intuitive.
That was it. So, thank you.
Okay.
Great. We'll just keep charging forward, keep going. So again, my name is Jamestaun Kraupp. I'm going to be talking about the last two steps, which is design and construction. So step 3 is designing an enhanced pedestrian crossing. Let's just jump right in. Of course, with any design, you need to familiarize yourself with the report that was just made. Nick kind of discussed how he got there, and really what happens is I take this, I read through it, just get context to the design and what are we trying to accomplish, what kind of features do we need, what kind of enhanced pedestrian crossing are we doing. Usually from a design perspective, real quick, prepare and go for a site visit, look on Google Maps, you see, is there anything you do know you need to look at? I take a smart tool with me, there are curb ramps out there, most likely going to have to inspect those. So I just get some quick measurements and maybe do an ODOT ADA assessment, some measuring tools as well. And then I always take my ride in the rain. You never know what notes you need to take, and it's Oregon, so it rains occasionally, and it can be very helpful. And lastly, your phone. Take lots of pictures. You never know what you're going to see, and it's just great to have that extra context before and after. Like I said, on the site visit, if I didn't do it before, when working with Nick, we do it together, but I'll usually confirm the site distance if it hasn't been done already, or it's coming from another report that isn't completed in-house. I'll complete an ADA assessment, or I'll even confirm it. I usually have that information just to get an idea of what do we need to do with the curb ramps. And like I said, take lots of photos. These are things that I take pictures of the curb ramps and their existing condition, take picture of pedestrians using the facility in its current state without the crossing. Those are kind of the best photos to, for context. Any utilities, storm, I take pictures of utility poles so I can understand what's on them, share them with PGE or any other electrical power company so we know how important are they. And then I like to take pictures from, if I was a pedestrian looking down towards the vehicles, what does that view look like? Preparing for design, the first thing we usually do after a site visit is we're getting survey, and I wanted to just discuss kind of the 4 levels of survey that we've kind of worked with and that I've worked with. And of course, it's always helpful. So the first level is no survey. Doing a design build, you're just telling the contractor where to put things, keep them very simple. Does not happen. I have not really done this one. It's usually in a very small scenario, but it is possible to do it. So this isn't so complicated that you couldn't. The preferred minimum for me is at least GIS, having an idea of where curb lines are, right of way, utilities, things like that. You can do fairly well on the design side of where you're going to place things. It just means more work later in construction, a lot of more field fitting, a lot more having to make changes out in the field. Level 3 is the local curb ramp survey. This is something we've done in Kittleson this past year or so with Peapot. Basically taking a small version of a survey crew, so sending a couple of people out and just doing a local survey, so setting a point in space locally at the curb return or in space saying this is elevation 1, and basing every other elevation measured with a survey tool to say this is 0.1 higher than the control, and making all those points and creating kind of more of a local map and outlining how the curb ramps can be redesigned. Could be really good for getting some general other utilities where they are in space. Very quick, probably a day's work for an intersection to do that, and you don't need a full survey crew. It's not an actual survey, so the licensing behind it is a little different. And lastly is level 4, which is the best you can do, and I will always recommend it because the more you have, the better. Is a full standard survey. Just getting, sending a survey crew out there, getting all the points, the curb returns, the striping, they'll get the utilities, things like that we can use. And having an actual surface could be really helpful, especially for the ADA grading portion. What can happen, you may need to do a combination of these things for budget, or maybe you already have some of it. But really, when you're thinking about starting off and you're thinking, okay, like how much information do we need? If you have a complicated intersection, the grading's really steep or things like that, you just want that extra security, I definitely recommend level 4. Otherwise, I've done a combination of them and we've made it work. Obviously, the most important things, capture utility locations. If you can do a curb ramp assessment and figure out the limits of your curb ramp construction, that's great. And figuring out power while you're in this phase, because most likely you're going to need access to it. So with every enhanced pedestrian crossing, the pedestrian is going to have to go from the sidewalk facility to the road, thus needing an ADA curb ramp or a ramp of some sort. You're going to be following ODOT, PROAG, and local agency guidance. Everyone knows that. I always like to do an ADA assessment before I start to get an idea of the limits of my improvement. Maybe you'll realize after the assessment, you only need to do a panel. It could be just replacing maybe the domes and getting those on there. Maybe you didn't have those before, everything else matches. Maybe you need to just adjust one of the ramps. Maybe you need to adjust the landing. But what you do need to remember is to change the grade slightly. If you're changing the landing, you're going to change the ramps, and then you'll need to do a transition panel. So, there's an order that you do need to follow. But as you increase the level of survey, it kind of increases your level of detail. So I have two kind of examples here. One on the left is for the project me and Nick are discussing. We didn't have a full existing survey of that area. We had existing line work, but couldn't find the surface to go with it. So we drew in something that we felt confident enough to work with the grades we had completed in the assessment. So the assessment told us, one ramp met close to ADA, but the landing did not. So we had to change the landing and then change the ramp, and we kept the ramp lengths the same. So we knew they would be fairly close to what was out there. And then we provided the contractor just the line work and a bunch of notes and made it very clear this has no survey work. You will need to do survey. You will need to check this when you are out there. And ODOT has done a really good job lately in this last special provisions and templates that they've come out with in their latest update of making the contractor a little bit more responsible for what's going on and doing a lot more checks, especially on the inspection level. The right side you can see is more detailed. I have grades, I have slopes. That one we had a full survey done, and I was able to confidently grade out a curb ramp crossing, and that is currently in construction over in Forest Grove. So I doubt I'll get any calls on that, or maybe just a quick check, and we'll definitely check them. But again, it's level of detail, level of effort. The left side took less effort, cost less on the design side. The right side, more effort, cost more. It just depends on your budget and what you're trying to do. The one big thing I did learn with design was if you're going to replace any asphalt, you need at least 3 feet to the gutter lip just to allow a hand compactor to get in there. Had an experience where I did only 18 inches because I thought it could work, and half of my road is solid, the other half squishy, couldn't really get good compaction. It ended up working out just with some other tools, but definitely recommend 3 feet of asphalt replacement. Otherwise you can replace at the gutter line. Pavement markings. So again, following METCD, ODOT, and local agency guidance, these crossings, the enhanced crossings, tend to use this staggered continental crosswalk. The left is ODOT's, very straightforward. And the right is actually WashDOT's. I just wanted to share that. They actually include a stop line 20 feet from their crossings. Not required, but it is a good idea. Maybe if you have a school crossing area, or maybe a low speed facility, wouldn't recommend for high speed facilities, 35 and up, but if you got like a school zone, could be really good as an extra precaution. Big thing, remember to use high visibility skid resistant markings. Very important, just because you have pedestrians walking on those and you don't want them slipping. Again, just some more ADA compliance with the pavement markings in these crossings. The left is the design, the right is the actual product. You need 48 inches from the face of curb when you're doing a parallel ramp as shown. And to kind of, what I did in this case is I had a marked crossing on the side street and I had the continental crossing. I actually just aligned the stripes. That way I could get that 48 inches in front and still be considered part of both crossings. Thought it was just a really cool way to kind of get around that problem, and it ended up looking great. Signage, also very important. You'll see who you need to follow. Choosing the sign that fits your situation. These are the most common signs that I've used. The W11-2 on the left is more of your traditional pedestrian crossing sign. You'll see it everywhere. The W11-15 is more common with roundabouts, but you can use it if maybe you're connecting mid-block crossing through a trail and you know you're going to have a high bike population coming through. Just a good reminder for vehicles, hey, you got bikes and peds. And then lastly, the S1-1 for school zones. If you're anywhere near school, along the school edge, highly recommend using those because it then does become more of a school crossing. Some other recommendations, if you decide that you want to close one side of the crosswalk to maybe prioritize or bring attention to the enhanced pedestrian crossing. Just a couple examples, ODOT's crosswalk close sign, everyone's very familiar with that. And what went into that. The right is PBOTS. Just want to share that as an alternative. It doesn't use the crosswalk close. It's more situated to visual language, so showing the pedestrian being crossed out. I've had used both in any scenario. Whether you use it is up to you. There's pros and cons, but you do not need to do it. Lighting analysis. So when we are putting in enhanced pedestrian crossing, we want to make sure we can see the pedestrian, especially at night. And really at the top, you know, I've described IES RP section 12.6. Maybe local agencies have some other guidelines they need to follow. But the most important part is to illuminate the pedestrian before or at the crossing. You don't want to put the light after, because then you're going to create a shadow on them. These are just two examples of where those lights can be placed. You can put a light on both sides. On the right, usually doing one is good, because then you don't get conflicting shadows, but I've done it both of these ways. My preference is the left, just as it's really helpful. Go ahead to the next one. You know, taking this opportunity also to upgrade any other lights. You can see on the left, I have the difference between the high pressure sodium and then the LED. You know, luminaires are fairly cheap and easy to do. It's the poles that cost a lot of money. When I'm designing these crossings, that's why I take pictures of utility poles and where they are, because I'll try to take advantage of them for lighting, and working with a local power agency, you know, tends to be PGE, because they're really good at getting out there. If I need another pole, you know, they can do a little offshoot pole, get power to it, and then the way they go about, they already have systems in place to get the city build for it, and then now you're not paying for a brand new pole that, you know, you possibly need to maintain. Again, it's just trying to find solutions for focused solutions for the crossing, because that's what we're focusing on. It's not the intersection. So a lot of agencies, you know, will kind of fall into this where you know, let's just look at the crossing. What is the before and after? And this is the lighting analysis that I did. I even looked at the side street crossings, so those were marked crossings, and seeing, okay, what are our existing lights out there, and getting the wattage of those from my site visit. But then, you know, if I replace them with LEDs, how's the crossing look? Where are my dark spots? Where do I need to put another pole? In this case, we ended up placing another utility pole on the northwest corner to help with the lighting of the crossing, which then in turn helped the entire intersection. Medians, as far as designing for these, you know, I like to use them because they help protect pedestrians and notify vehicles on the approach. Really easy just to do a dowel raised median. You can see on the right what that looks like. They just form it up at the asphalt. They're going to drill a couple rebar posts in there, and they'll just pour the concrete. You do need to be at grade for the pedestrian walkway, so make sure that is meeting your grades if you can. But it's a square, really easy to cut out and pull it out and replace it with concrete. And it's very important to look at nose geometry. I kind of took a piece out of the NCHRP 672, which is the roundabout guide, and it actually talks about designing medians. And so applying those same geometric concepts to the approach, I think, is really good, and allows vehicles on the approach to see more of the median when it, you know, kind of tapers out and in like that. And lastly, when you're doing a median, don't forget the object marker. You know, we have different machines, maintenance coming through, especially during the snow. If there's snow, any plows, or at night, we want vehicles to see that there's an object in the roadway. We don't want them tearing it up or running over it. So again, you know, these are some other, these are all the examples of enhanced pedestrian crossings. I've highlighted the rectangular rapid flashing beacon because that's where a majority of my work is. That's the most popular. It's the cheapest of them in most cases. So a lot of my experience speaks to that, but a lot of these concepts you can apply to the other types of enhanced pedestrian crossings. continuing with design, specifically for an RFB location, you want it to be visible to vehicles, things like that. You don't want to block pedestrian view from vehicles and vice versa. And go ahead and push next. You know, this is a case we had multiple RFB posts because we had a lot of utility poles we couldn't relocate. So no matter what, a vehicle was going to see something flashing and realize they needed to stop. Go ahead and edit next. When doing a parallel ramp, things to remember, in this case, I had to separate the button from the RFB. You need at least 5 feet in front of it for ADA access and for turning space. Go ahead, next. We also, if you're doing more of a perpendicular ramp, you need 4 feet for clear width. In this case, they had placed it at the top of the ramp. They need to maintain 4 feet of access through there. If you're gonna, as far as the two options, I'm gonna speak more to RFBs. The other ones are kind of self-explanatory with power. Solar is great if you get lots of sunlight, you don't have a lot of trees. They're radio activated, so you don't need to connect them via conduit. And manufacturers will actually do the solar report and tell you which direction to face the solar panel, which can be very helpful for your plans and being specific. The batteries have come a long way, especially in the last 5 years. They actually last a lot longer. And during the solar report, they'll actually specify the type of battery you need and make sure it'll last for your use. Obviously, if I have school crossing, it's going to need a different type of battery than a normal, you know, maybe mid-block crossing in a rural area. Hardwired, more reliable during storms and cloudy days and at night, but they do require a service cabinet and they do require some sort of conduit trenching. Most likely, if you're crossing a street, to connect them, horizontal directional drill, and those have a cost of at least $10,000 minimum. So again, those just add one of those things that adds to the cost and you should account for when you're trying to figure out how to maintain them. Some agencies do like to maintain the powered ones, and that's perfectly okay. There's nothing wrong with that. These are just your options. Mounting, a lot of times you'll see, you know, a couple different versions. There's the perforated steel square tube, which you can use with the solar powered, and they can actually be placed directly behind a curb. So you still get that ADA reach minimum that's required by ODOT of 10 inches. So really helpful, especially in a pinch. Otherwise, you know, there's just steel tube, frangible base that ODOT does. They do have a PSST version. But the steel tube is required by ODOT, especially if you are doing hardwired to protect the wires and to allow access through the frangible base. They just take up more space. You can also mount to a light pole. In the project Nick and I did, we did that. So, and that's a picture of it. We just had to coordinate with the city of how that looked and how they were going to do it. I will remind you, you do need to separate the button from that, from the light pole. Usually they don't like to combine the two. Other considerations, stormwater conveyance, you know, where's the water going in front of your ramps, things like that. You might need to add an inlet, making a connection. Traffic control, you want to make sure you're maintaining pedestrian access during construction using a TPAR, and making sure, you know, you're taking, making pedestrians go the right way or go around your project if you do have the room. And erosion control, very straightforward design aspects. Quickly on cost estimate, increased costs due to small quantities. So you're only doing, you know, 100, 200 square feet of concrete, not, you know, hundreds or 1,000. So that does increase the cost. Obviously, PED signals or anything with a signal is more costly than RFB. That can be just on posts. Hardwired, like I described, is more expensive than solar. Some basic dues that I have is mobilization is at least 10,000 minimum or 10% of your overall budget. Or HDD, you know, that drilling 10,000 minimum, even for 50 feet. They got to get the machine out there, the amount of work it takes and setup. And then if I'm doing RFBs, because that tends to be most of my work, you know, I'm guessing around 12 to 15,000 per post. The key thing there is all that cost is majority electrical work. So wouldn't be surprised if civil engineers in the future end up becoming partly electrical engineers just to reduce cost. But that is why, you know, RFBs can rack up in cost if you have more posts, just because they are fairly expensive, but are cheaper than an actual signal. So that's good to keep in mind. Quickly, construction. just to go through this real quick. You know, problem submittals, things I see wrong, getting the RFB submittal wrong, or calling out the wrong type of flasher. You know, maybe you have one-way traffic and they specify two-way flashers. You don't need that. You know, detectable warnings, things like that, or calling out the wrong type of sign. Making sure you know, you have temp ADA facilities for traffic and ped control if you do need them. Making sure you understand where your pedestrians going while you're constructing these curb ramps is very important. ADA curb ramp grading, obviously you're gonna have, you know, changes in the field of that depending on your level of survey. Go ahead and hit next. You know, pole location can have about a 6-inch variance. This is where the vac truck came in and got the foundation hole ready. But you can see you have no idea where the surveyor staked the pole. Hopefully it's in the center of that, but you know, ADA is important, and when you're off by 6 inches, it can have a huge impact. So, you know, try to give yourself some buffer and think about through that of your location if you can. Unforeseen utility conflicts, sometimes you don't know where all the utilities are, especially if you're using GIS, or, you know, it could vary. I've definitely put poles on top of utilities and had to adjust. Go ahead, next. Recently I did some striping and it was peeling. The contractor had to do it a few times, so that's a very common thing for people to run into, but with these projects, you know, take extra caution of those because it is a big part of the project. And once you're done, do your final inspection and use the crossing. I definitely have a few. I should have got some pictures of me using the one near my house, but I definitely, you know, go ahead and use them a few times, make sure they work, and helps me understand a little bit better. But nothing's better than using something you've designed. So ran through that. I've seen a few questions come up. Firstly, thank you everyone for your time. I know we're kind of a few minutes here. If you have to go, hopefully we can follow up. Nick and I have our contact. I'm sure that information can be given out. Otherwise, we can take a few questions.
So can you see the questions, or do you want me to pull them up here?
I like it when you say them. I feel like a real panelist.
Well, the first one is from Timothy Gross. He says he has a pile of pedestrian closed signs in his public work yard. They get hit on the corner by people pulling trailers. Any suggestion on how to resolve?
Yeah, so that can be really hard because they do need to be towards the face of the curb to prevent people, specifically those who are visually impaired, to feel them when they try to cross where they shouldn't be. Really, you know, at that point, I don't have any ready solution for that. Probably creating something that is, you know, how they're mounted could be easily, you could do that instead of, you know, maybe putting the pole base straight in, mounting them more to the top of the concrete so they do fall over. Maybe you're just bolting them back. Otherwise, yeah, from a maintenance perspective, maybe reassessing, do you need that crossing closed? You know, how often is that crossing being used? Things like that. But if you do need to close them, I think I don't have a direct solution for that problem, but that is a very good question.
All right, next one is from Janet. I don't know how to say your last name, sorry. Are you finding that you need a light on all 4 corners? Have you found that 2 corners ahead of the crossings work? Issues with vertical versus horizontal luminance. 4 can be a lot of light when there's no corridor lighting.
Yeah, so usually when it's just for the enhanced crossing, I find that 2 is good just to increase the lighting of the crossing. And really what you're trying to do is create a better scenario than you had it. So a washtop in particular requires that the lights actually be placed about 20 feet prior, exactly where their stop bar is. So they found that with that, given, you know, that can help with the lighting. If you're having problems with getting things lit using a brighter LED, PGE has a really good list, and doubling the light if you want it even brighter. But definitely that, you know, that horizontal illuminance portion, you know, what does the vehicle see on the approach? Placing your light, you know, before helps with that a lot. When you place it over, it definitely puts that into perspective. But it depends on your agency. Again, A lot of agencies don't require the horizontal illuminance. They only, you know, want the square footage area. But if you do care about that, definitely recommend putting the light before. Otherwise, all four corners might be a little overkill because, again, we're focusing on a crossing, not necessarily an entire intersection.
All right. Next one's from Emma Newman. What is the latest documentation on the solar RFBs working better? Our maintenance staff, I believe, are still opposed to them since they were constantly having issues with the solar/battery situation.
Yeah, so the batteries have come a long way in the sense of they used to be the problem before was you know, they would have to replace the batteries often, but battery technology has come a long way. As far, I don't have any documentation of how they've gotten better, but it is something that you do need to think about when maintaining them, and that's where hardwired might be more of your preference. That way you don't have to. But I do know, based on conversations I've had with some other maintenance crews, that the batteries are getting better. They are lasting longer. It's just, it depends on your scenario. Are you in a very sunny area? Are you not? Because that'll dictate how often you're using the battery. And that's where the solar report is very helpful, because they can actually tell you, hey, you know, you're going to need a really big battery all the time because you're not getting enough sun. You might want to think of a different solution.
And I know from project experience myself, we've tapped these RFBs into the lighting circuit. We've worked with PGE when everything's option A to establish a rate so that we can still get these in without necessarily having to install a BMCL as well.
Yeah,
Or
they
if we're
don't
doing lighting on the project, we generate a circuit just for the RFBs.
Yeah, and they don't take up a lot of power. They do very little load on the system, so they're really easy to tie in.
And Mike McCarthy asked, what RRFB suppliers provide good product? Any preferences? I'll start off real quick on that one, Jamestaun, because I just went through this. ODOT's blue sheets, green sheets, whichever one it is, they've only got two providers on there, the Carmana and blank Tapco, I believe is the other one. I believe they're both pretty good products. I know Clackamas County prefers the Carmana for whatever reason, but there's only two now on the ODOT list in a way. James,
Yeah.
have any others?
No, that's the same thing. I always start with the ODOT green sheets and figure out what's okay. Some agencies like to specify one type. I did have a project recently where we decided to allow the Tapco in just to see how it would affect bidding and to allow some more competition among that item, just because it can get expensive. So, you know, some contractors maybe have some extras, or they just have really good relationships and can get them cheaper. But the two that ODOT have specified, I can't really tell the difference between them, and I haven't had a problem with either of them yet.
Next question is, ODOT has gotten very strict with tolerance on ped ramps. Consequently, local contractors have been adding risk costs to ADA ramps because they have to replace them so much. It seems that the tolerances are exceeding the capabilities of the trade. Can you comment on the cost increases associated with pedestrian improvements in ODOT right-of-way?
Yeah, so that definitely is happening. When I went and got my inspector training back in February, before the pandemic, they kind of talked about that and how their costs are getting, you know, close to $5,000 to $7,500 per ramp. So, you know, when we're talking about the amount we need to do, that adds up. Really, ODOT's take on it, and you can see it in their new spec language, is they're trying to put more responsibility and upfront review before construction. They found that through communications with other DOTs that you know, we do the design, that gets approved. The contractor actually needs to review the design and verify it prior to even demoing the area. So that's getting a surveyor out there, taking some, you know, quick elevations and figuring out, does this work, and doing an iterative review process to make sure it works, and we build it once and we build it right and not build it a few times. Obviously, when you're doing a design build scenario with less information, as I described, you need to be careful and really assess the risk and If you're in a flat area like we have in this photo, which is from Tangent, Oregon, was their first ADA project and crossing in their city and town, which is great. It's fairly flat out there, and they did do grading, and it just helps. But sometimes it can be quicker to save that money for construction. So it's kind of using your engineering judgment. But as far as tolerances, contractors are accounting for it. But really, you know, putting that language in your specs and holding them to it. Just they need to make sure they check those things, and everyone will be happy for it. It's way easier to check it and, you know, measure it twice, cut once. But those costs are going up, and you know, there's not much I can do about that.
And then last one is a comment from Derek Robbins, just saying, make sure you specify proper electrical conduit sweeps. If you're doing a shallow bore, you could have a problem with the standard 36-inch sweep, and you may need a 24-inch sweep. So it's something to point out to everyone. And then a couple of clarifying things on some hard lessons. Well, thankfully not hard, but lessons learned within the last couple of weeks with these is make sure you specify APS push buttons now so that we're ADA compliant and you get that audible message that the flashers are on. Because if you don't, that could come at $1,000 per push button change order. I'm sure it always costs more to change order it than get it in the bid the first time. And then the second one was on stop bar. If you have a multi-lane crossing, like the WashDOT example that Jamestaun showed, if you're crossing multiple lanes, you need to have that stop bar in about 25 feet before the crossing. And that's so that as a pedestrian's crossing, one vehicle doesn't stop too close to the crossing and block the view of the crossing pedestrian. If you keep both vehicles back, then that pedestrian is visible for the entire crossing. And that's actually illustrated in ODOT's traffic line manual as well. It's not on the standard drawings, but it is in their traffic line manual. So you can look there. And then Emma just popped up a question. Are there any regulations on consistency of the audio, any bilingual requirements? I haven't seen any bilingual requirements, but I know we've done that in places where there's definitely more of a bilingual community. It just depends on where you are and what you program those to be. And they could be anything just from the tonal push buttons. They don't have to necessarily save the street crossing. It could just be the tones that you would use as well. But for those, I would refer back to the MUTCD and PROAG and ADA codes. But we have been putting APS buttons on RRFB crossings. So.
Yeah, very good points, Fred. I know you've done a lot of these too, so always a great resource.
And then Andrew Halliburton said, good info and thanks for the presentation.
Thanks, Andrew.
And Jake Weiser says, get a haircut.
Maybe, I'll think about it.
So if you guys don't have anything else and there's no further questions, we'll go ahead and wrap this up. The recording will be put on the chapter's YouTube page, and save your flyer and confirmation email for PDH credits for OSBILs if you need that. So, thank you all and have a great day.
Thanks, everyone.
Thank you.